All right, so I have the privilege of introducing our first speaker, Dr. Murin. Forgive me if I pronounced it incorrectly. Prefers to go by Daniel, um, and he's a senior staff scientist at Scripps Research, studying how antibodies enable natural killer cells, or NK cells, of our innate immune system to target HIV to help inform the engineering of HIV antibody therapeutics and vaccines. So exciting. Daniel is the very first recipient of the Stephen ICATS R01 grant from the NIH, a new initiative targeted to early stage investigators, which was just announced in 2021. So big congrats there. We're very excited to have Daniel here today for his talk titled Winning Your First Major Grant Without Data. If your grant application involves a change in research direction or maybe has little to no preliminary data, this session will provide you with some great insights on how to best leverage your proposal. All right. So again, without further ado, I forgot to turn my video on to show my face to say hello, but I'll turn it off so I don't save your bandwidth. All right. And I'll give you the stage. Thank you so much, Daniel.
Thank you so much for that introduction. I am gobsmacked with the amount of people here. So exciting. So hopefully everyone gets a little bit from this. And even though I'm talking from the perspective of someone in America, I do believe that I'll be able to hopefully appeal to people all over the world. So let me just get this going. Let's see. Alrighty. So I'm going to be discussing sort of my journey with getting this R01, and I was the first one to receive this as far as I know in the United States, as it was just announced at the beginning of last year. So it's very new and not a lot of people know about it. So I hope that people learn a little bit more about this grant, and then also be going into sort of how BioRender was integral into my grant writing process. So what do you do when you don't have any data and you want to get an R01? Well, Stephen ICATS was the director of the National Institutes of Arthritis and Musculoskeletal Diseases from 1995 to 2018, when he unfortunately passed away. But he's always been a very strong advocate of early career scientists and getting them training and mentoring, as well as providing opportunities for getting money for funding their research. So as a part of the NIH initiative to do this, they decided to create a new R01 that would be significant funding for early stage investigators. So the point of the R01 was that it would allow early stage investigators that didn't have a lot of data to be able to compete for substantial funding that would not necessarily be available to some of the more tenured professors that would be competing for these same grants. So these grants would be scored separately and they would have separate criteria. And one of them specifically was that this would be a new research direction for the PI. So it couldn't be something that they've already been doing for many years. And one of the most interesting and challenging parts of this grant is that no preliminary data is allowed. So I came into this with some great ideas and didn't have any data after failing to get a couple other grants. And then this kind of popped up on my radar and I thought it would be a really great opportunity. So I'm not going to go into all the details of exactly what is involved in getting this grant, but definitely more information can be found there on that link, and this recording will be available so you can follow that. So just to tell you what an ESI is, this is someone who has completed their terminal degree, whether that be a medical degree or a PhD within the past 10 years and has not received significant funding. And what is considered substantial, there's sort of blurred lines for that, but myself, I had no funding at all. So I started with finding the PA, which is the program announcement for this, and you can find that online still. That gets updated periodically, but right now I think it's still open until sometime in 2022. From there, I decided to let my admins know about this grant, and figured out all the deadlines. So that was sort of the first big one, is figuring out the deadlines. From there, I would encourage everyone to do this when starting a grant. You need to identify, especially at the NIH, who your program officer is. So for the cats, there's someone you can contact when you go to do your research online, and you can email them and find out who your program officer is. And loosely, I just sent in my CV and said, this is generally what I'm thinking about doing. And then they will try to match you up with someone where they believe you'll be, most appropriately guided. And then from there, I decided to start looking at other successful R01s. Now, since there were no other grants awarded for cats, I had to sort of look at equivalent grants, which are indeed R01s. So I talked to my PI, talked to my colleagues, and started looking at R01s. So the grant is composed of several sections, and you definitely need to have all of these that you'll be submitting through an online process. But I'm going to just point out a few of the ones that are most important and sort of the direction I took for this. So I started with my specific aims, and I'll show you kind of what that looks like. And I think this is a great way to sort of outline what you want to do in your grant. Typically, there's 2 to 3 aims. I wouldn't go any more than 4. You can also do sub aims. So that's just a great way to, it's one page, you start with that, and then you can go from there, and it makes it a lot easier. From there, then I'd write a abstract or project summary. There's a limit on the number of lines. I think it's 30 lines of text. And this is a great thing to start in the beginning as well, once you've done your specific aims, because that will be followed up with letters of support. Since this is a early stage grant and you don't have preliminary data, you have to build a story of, I've got a network of people that can support me in completing this research, and they'll provide me the guidance that I need going into a new field, a new direction for myself. So having that summary is a great way to reach out to your colleagues or potential collaborators to say, hi, I'm applying for this grant, it's new, and I would love your support in this process. Here's the summary of what I'm planning on doing. Definitely the most important part of the grant is the research strategy. So I'll detail that out, and you definitely want to cite as you go. I use ReadCube, and I just absolutely love it. So if you've never used it before, I think it's way better than any of the other, I mean, you can fight me on this, but I think it's way better than any of the other citation software out there. And then one of the other most important parts, and I think that was sort of crucial to me getting this, is the new directions page. So this is a special part of this R01 that isn't typically required in standard R01s. It's a single page, and I'll go into detail on what that involves. Facilities equipment, you can pull from existing resources. Often there'll be colleagues at your institute that would already have these wherever you're proposing to do your research. There's a biographical sketch. This is also standard for the NIH. They just changed the way they did this recently, so you want to make sure that you talk to your PO about how to get that done, do your research on that, but you have to fashion it for the grant specifically. I wouldn't just pull the one that you used previously. So just some general strategies on writing the grant and starting with the specific aims page. I actually used a figure that was mostly generated from BioRender in my specific aims page. So it's a great example of showing how much space it actually takes up. So I'm really emphasizing the use of visuals and downplaying words. When I do use text, it's condensed as much as possible. So often I'll write everything, and then I'll go back and I'll read a paragraph, and I'll say to myself, how can I squish this down to the least amount of text possible? I think that's pretty given, seeing as there's only so many pages allowed. I think there's only 12 allowed for the research strategy and a single page for specific aims. But something I think that was very helpful in this instance was the use of keywords. So you can see some of those listed there, and then they're reflected in my grant page here, where I actually highlighted and emphasized these specific keywords that I'm working with. And then using bold, italicized, and underlined statements really help these readers, these reviewers hone in on things that are most important, and makes it a lot easier to read. So from there, you have your significance pages. This is all a part of the research strategy, which is 12 pages total. And again, since this is available, I'm not going to go into these details, but it's there listed for you as just a helpful guide in outlining your own grant, especially if it's your first R01. So there's significance section, which has several subsections that I wrote about a paragraph or so for each one. Your approach is by far the longest, so this is detailing in every little thing you're planning on doing. Sub-aims go here, experimental methods, and then you end with summary and expected outcomes. There's also, I think, a very important section that helped me out a lot was scientific rigor. So how are you going to integrate scientific rigor into your grant? Talking about sex as a biological variable, especially if you're doing biology, it's extremely important to include a statement in there. And then I leave the very last paragraph as sort of the final punch. And you can say really anything that you want to in that section about where you're going in the future and sort of like how you're going to save the world with this R01. So as I mentioned earlier, there's also this insert, which is the new directions. And this is really addressing the core of the program announcement, which is how is this a new change of direction in your research? So I kind of took a narrative approach to this where, again, you can read this if you want later on, but it's really a story of how I came up with my idea, sort of that epiphany moment, and then how that pivoted me in a new direction. So a great way to do that was I used this table. And again, I just sort of made this up because I didn't have anything to go off of. But maybe this will be a great standard for other people applying, where I sort of summarize these topics, such as what I'm studying, the type of technology I'm using, the virus, in this case, the biology I'm looking at in the field of study, and how I had experience in that area, but then how I was changing the direction. And so for reviewers, this makes it very obvious why you're very well suited for this program announcement. And then the last thing I want to say on this before I go into sort of the figures is I also then at this point had decided where I was going to apply. So you can find out who's in the study section and start going through who's going to be in the study section, look at their own research, and choose study sections that are going to be appropriate for what you're doing, but where you're going to have reviewers that are most excited about what you're doing. And then you can request in your cover letter for your grant to be sent to that study section. And you can include keywords throughout your entire grant that will be appealing to those reviewers. So my approach to figure making, especially with BioRender and any time throughout my career, has always been that a figure should speak for itself. Anyone should be able to look at this figure and know exactly what's going on without the use of text or explanation. So I really love BioRender for that because they have a lot of standard symbols, especially since I work with antibodies, receptors, and cells. It was very, very easy to assemble. I like to, here I'm highlighting like an overall concept if I'm studying NK cells and infected host cells, but specifically I'm interested in mechanisms. So, I did a pop out, and then I'm using colors across the rainbow to indicate these different sort of types of antibodies that I previously studied. But again, using pre-made BioRender icons that are in their standard colors that are already well chosen and appealing to the eye. No need to change any of that. Really helped with this. And again, sort of the minimum use of words and just trying to keep the core concepts very simple. I like doing these circles or blowouts where you can sort of indicate things like that. But I think that just having a figure that speaks for itself is crucial when you're applying to a grant with a broad audience of reviewers. So developing a figure in BioRender, I always start with a sketch. So this is an early sketch of one of the figures I wanted to make, showing sort of like a technique that I was planning on using. And obviously it's very, very rough. And I did kind of go through rounds of this is working, this isn't working. But unfortunately, I guess I didn't save those. I only have sort of the final figure. But I guess the point I wanted to make here is that sketching out your ideas and then using, again, like pre-made symbols in BioRender makes it very, very easy. You can just simply take an element from your sketch search for what you think that is. In this case, I say like apoptosis cell. There's a really great image of that, and it made my life really, really easy. And also, it's a lot easier to sort of organize how things are going to be laid out in a sketch and then go from there. So the big thing about this grant is that I didn't have any data, but there was data that existed in the literature. Specifically, I was using a new type of microscope called MinFlux. And this is a really great figure from one of the seminal papers on MinFlux. But some of the questions I was asking is, what would the data look like in real life? And here's a great example. What worked and didn't work in their figures? And how can I distill this down to something that's going to make sense to broad reviewers? And specifically, I want to make sure that it's understandable, not just to an expert, but to a general audience. And so then you can be sure that even though your scientist reviewers are very, very intelligent, they may not know a lot about the subject. You're not going to be insulting their intelligence by distilling things down. So that then, I translated into, what I would say is fake data. What do I expect to see? So I had a nice 3-panel section where I showed the experimental setup, a detail of what I think, what the hypothesis is of what I'm going to be looking at, and then how that translates into quantifiable data. So again, I have sort of what's the instrument I'm going to be using. I need to get work with PyRender on getting an actual MinFlux. But what does this look like? How do I set this up? Again, I used color to depict time. There's great tools in PyRender for making this happen with gradients. All of my labels were done in PyRender. And then that's translated to obvious phenotypes that I'm trying to see, where I've got one high ADCC with fast motion, one with low motion, no ADCC. So very obvious differences in phenotypes with colors, visual depiction of your hypothesis, sort of just lining things back up. And then using preset colors again, really pleasing colors at contrast that are already set in PyRender, preset shapes, and then the use of curves made this something where I basically went from what does the data look like in the real publication to what do I expect to see in my particular instance. And then the last thing I'll kind of close up on before I take some questions is the great templates that PyRender has been acquiring. So one thing I wanted to show in my grant was how this new technique of MinFlux was different than typical techniques. And there's a great template on what STORM is, which is a type of super resolution microscopy. So I kind of then picked and chose what I liked and didn't like, added in some real data from confocal STED and MinFlux data, and then put it together for myself. These are very easily editable templates, and there's, I think, probably thousands of them at this point. And then the kind of final figure in my grant got distilled down to something that was really simple, which is, what is MinFlux and how does it work? So with that, I'm going to just close up, but I want to thank people at Columbia and Scripps that wrote me letters, guided me. I did a lot of editing. I started very, very early, and I had a lot of help from my administrative staff. My program officials, Udesh and Carr at the NIH were seminal in this process. I talked to them before, after. They told me that they were in the room when my grant was being reviewed, that there was a lot of excitement about it, and they just were so important to this process. And then you can find me on social media. I'm working on starting a lab, and I'm applying for faculty positions. Website coming soon, but I do have money now, and I'm hiring a postdoc. So if you or anyone is interested in MinFlux nanoscopy and doing some really great immunology, please send me an email. I would love to talk to you. And I'm open for questions now.
Fantastic. Thank you so much, Daniel, Dr. Murin. We've got a lot of exciting questions in the chat. Also some pre-submitted ones from a previous email, but why don't we kick it off with some interest in the grant itself. So are they able to apply if they are outside of the US, or if they are a non-US national working in the US at a US institute?
Yeah, that's a really good question. And I probably should have looked this up before. I don't want to give the wrong answer. So I would just say, let me find out, and then maybe we can disseminate that information later. But if you go to that link in the first slide that I presented, I'm pretty sure there's a lot of Q&As, and that's one of the questions that comes up. And so you can probably find the information there. So I won't answer that just because I'm not 100% sure. So
Sounds
apologies.
good. No, no, it's very exciting to at least hear about it. I think it's new for a lot of people here. And perhaps this could also be within that follow-up, but if you'd like to answer now, do you know if receiving the cats make one ineligible for early stage consideration when applying for regular R01 as an independent investigator later on?
Yeah, I do know that definitely it does. So once you receive this, you're no longer an ESI. So I guess the point being is that it is a regular R01. I can disclose that I'm getting on the order of about $250,000 a year. I would say ask for as much as you can. Budget is not considered in the review of the grant at all. And once they decide, we like your grant, we're going to give you a good score, then they look at your budget. If you ask for more than $500,000, you have to submit a supplementary part to your application. But I would ask for the maximum if you really can justify it. And yeah, once you receive this grant, you're no longer an ESI.
Excellent. And can you apply for this grant during your postdoctoral fellowship? Was
So
that one of the other
you
questions?
need to have principal investigator status. And if you're a postdoc, I don't believe you can get PI status. So I had to write to my department chair to get PI status once I was promoted to a staff scientist. And so that's sort of where I'm at. So I would say no, you cannot. You need to be a principal investigator, and usually that requires you to be at least the staff scientist level or above. There is kind of, I'm in a pickle because I don't have my own lab. I'm still working for someone else, and I'm not a faculty member. So I would caution people until you're, I think this is probably more geared towards assistant professors that are just starting out. But definitely I was able to get it. And I think that, it's been very, very helpful for me, and it probably will make it easier for me to get a faculty position.
Excellent. Thank you so much. And I think there was something similar. Let's see here. A question about them pouring in. Sorry, I've lost my spot now.
Fine.
Um, it was shocking seeing that you can create a figure with expected data. Is this a normal approach for starting grants, i.e., when do you have tons of preliminary data?
Yeah. So,
Oh, yes, when you do not
so
have
the
tons of preliminary data. Yeah.
yeah. So I mean, I guess the typical process is you've been hired as a faculty member, or maybe in your senior postdoctoral position, you were able to start on something and your PI was great and let you take that data with you. And so 3 or 4 years into your position, you're like, I have enough data to now apply for an R01, which typically are very stringent in the research that you're wanting to do needs to be extremely well supported in both the literature and in your own preliminary data. So in this case, that's not what I have. So yes, I had to be very creative. It was a lot harder because I didn't have actual data to pull from. So that's why I think BioRender is extremely helpful in this particular grant, because it makes everything very cohesive. You're able to recapitulate figures in from say similar kinds of data that have been processed or published already. And I think it makes your grant look better because you're not just cutting and pasting data from another paper and saying, well, this is similar to what I'm doing, I think it's going to look like this. You sort of can tailor it to exactly what you're doing. So it's definitely more challenging and different, but it provides cohesiveness to your grant to be able to kind of make it up yourself. It just takes a lot longer to do, but it's absolutely
Mm.
required because you simply can't show any preliminary data. Your grant will be thrown out from the review process and thrown into an R01 pile that you probably won't be competitive for.
Mm. Great. All right. Still got lots of questions coming in. They're really enthusiastic about your talk. So tons of clap emojis. I've got a couple folks that said that they've followed you on Twitter now. And if you're open to collaboration, I suspect you might be able to connect there. And if you don't mind, Dr. Murin, if you could maybe sit back and help type some answers up to some of the questions, if you're able
Yep.
to. While we move on to the next speaker. This is fantastic. Thank you so much. Great
Yeah.
example of a great communicator,
Yeah.
visual, spoken, written, and very succinct. So thank you so much again.
Yeah. And please feel free to email me too, anybody, but I'll go through the questions.
Thanks so much for your generosity. Thanks.